this topic. So this will be the agenda for discussion. So functions. So we'll have a very detailed discussion on functions. So what functions are. So if you guys have any programming background, like whether it be Java, C, C++, whatever. So we'll try and check some points which are common, some points like what is distinct here, what is unique in R, which is not found in other programming language. Okay, we'll see different aspects of function. We see argument, parameters. Okay, so we'll see what makes functions in R difficult and what is good in R. Right. So we yesterday we also saw a lot of filtering techniques. We used to filter with the base package. Whenever we had a data frame, we imported a data frame sample data set, and we started filtering based on logic. So that was base package, as I said, and here like in real time we generally use a lot of data, and in that case we generally need advanced packages like R, dplyr or plier. So they both are almost same, or plier. Okay, so but what we'll see today is dplyr. Okay, so we'll see how to install dplyr and how do we use it. So what are the different grammars that dplyr has. Okay, going ahead, we'll see some lot of exercises. So that's what will make our hand free on dplyr. And then if time permits, so we'll have something called apply family function. Again, this is very important, and this is all because this is important because this will optimize our coding time. So like something which will take 10 lines or 5 lines or 8 lines of code to do some stuff, you can do it in a single line. So we'll see this. Okay, fine. So great. So fine, let's go ahead. And I remember that we started discussing yesterday about functions, and we like stopped. So what I was saying yesterday is, so if so far till now we have seen a lot of uh, functions that we have used, okay, unknowingly, unknowingly. So some of those functions that we have used are this: summarize, mean, max, and length. Okay, minimum, maximum, length, and there are many others as well, right? So if you can recall, we used something called uh, like what was the function that we used here in day yesterday? Um, Median. Yeah, so let's say one of the function was median. So median is itself is not very simple when you have a very large data set. So it is a huge thing, like and then you have uh, like a standard deviation, SD. So these all things are very complex, and it needs some 2 to 3 lines of calculation and concepts. But in R, and they have it build it in themselves, so you can just call the function and use it, right? So do I need to write a logic from scratch? So how do we like use it? So there's something called in any programming language. So there is something called uh, system defined function, system defined functions. Okay, and there's something called user defined function. So whatever we saw so far, like this all are the example of system defined function, because this is created and you just need to use it. So this is created and stored in R, so you just need to use it. Okay, but many a times when you start working in real scenarios, so you'll find that there are something which is not happening, that is not going well with your logic, your thought process. So in that case, you'll have to develop something of your own. Okay, so in that case, and if you do it once, so it's fine. But if you want to use that concept, that particular thing, logic again and again, so it's always better to create a function, so that it will save your time, so that you don't need to write the same code again and again. Okay, so that is the advantage. Now to see the function, so obviously you have a help section, so you can see what is SD. So if you run and check what is SD, so you'll get the complete documentation. So since it's a user defined thing, system defined thing, so they have created a function as well as they have created a document of it. Okay, so what this does, this is system defined function. This we use it for getting the standard deviation and all those things. But when you like if you want to check the see the structure, what your SD is. So there's one command called str structure, okay, and you do SD. So some function has a code written in it. So here they don't have it. So maximum, like whichever is matured function, they don't have a code. But whenever you define a function of yourself, okay, you'll do str structure and your function name, your first function name. Let's say first function name. So what will happen? So you'll get the logic which you have defined in the function. So so that you can, anybody who is working on that code, they can understand what you have written inside the function, what that function is actually doing. Okay, that was one thing. So we now understand what is system defined function, what is a user defined function. Okay, the second thing is we'll see that whatever we have listed above this, all this, so whatever we see, we understand that what is the use of the function, what is the use of mean, what is the use of max, what is the use of mean, length, median. Okay, so the function name, so this is what function name only. You have function name, and then you give a braces. Okay, you have a bracket. So under bracket you pass on the parameters. So whatever you pass inside the function, so you have function, and then you have a, if you press tab, so automatically you'll get a two brackets. So that means by default it accepts this bracket. Okay, so this is your function. You see it in blue. So this is a code, like keyword, and then inside you need to pass x, y, whatever. So this is your, whatever you're passing inside is your parameter, right? So let's quickly, we'll see the detail, but let's get quickly into like the function definition, the how do we define a function. Okay, so we have three things we'll see, which is function argument, argument matching, defining a function. So let's start with defining a function now. Okay, then we'll come to argument and function argument and argument matching. Okay, so let's see what is the syntax. So syntax is, you first give a, like create a function to give a name. Okay, so so sorry. So what we do is, let's say my first function, let's say func. Okay, we write this. So this is the function name. You have declared that I'm creating a function with this function name, right? Now, so now we write a keyword called function, and automatically there will be a bracket. Okay, then inside bracket, let's, whatever we pass, that is a parameter. Okay, we also call it argument. Then we give a curly braces. Just keep a note of a syntax, otherwise you'll uselessly get into what is the parameter, like what is the bracket, and that's confusing at times. But initially, since you are learning, just keep an extra note of it so that it does not create such issues. Okay, so the moment you give a curly braces and enter, so there will be a indentation. So see here, your cursor is blinking two space from the left. So don't change it. So start writing code here only. If you change the indentation, we call an indentation actually. So this might result at times in an error. Okay. So now here we write, this is called function body. Function body. Okay. Or function definition. You are basically defining the body here, function definition. Right, so here we write, let's say I'm passing x, this is my x, okay, and I want something x square. Okay, so I'll simply write x into x. Okay, then let's come here. Okay, so far what we see on the environment, we see data, we see values, right? So this is like whatever data you upload, whatever data frame you create, so this comes here. If you click here, you get all the details and structure of that, right?
So
Yeah,
that x should be small, I guess. That's x into x.
yeah, so yeah, fine, no worries. Okay, so the moment you upload a data, create a data frame, so this will be there, this will get populated. Okay, the moment you create a variable, whether a string, character, integer, whatever, so this will get populated. Okay, the moment you create a function, so then you'll see one more section called functions, and the functions will be started getting populated here. Okay, so let's see. uh, let's create a function. So here you have functions and your function name. So this is your function name, my first func. Okay, and in that you are basically passing how many parameters, and that number of parameters will be there. So you are passing one parameter, so it says function x. Okay, now let's go ahead. So I have created a function with this name. Let's copy this name and call this function. So this is function definition. Okay, function creation, let's say function. Okay, then you have function, calling a function. Okay, how do I call a function? I give a function name. Okay, if I enter, I'll get an error. I'll get the function which I have created exactly. Okay, with the codes. But I want this function to get evaluate and give me the exact output for which I have created a function. That means I want this evaluation. So for that, you'll have to give a bracket, pass on the parameter. Let's say I pass parameter 10. Okay, so 10 will, this function will be called, 10 will be passed here. Okay, so this is a function of x, so 10 will pass here, it will come here, 10 into 10, 100. So 100 should be my output. So once I run this, so I'm getting 100 as my output. Okay, so this is my first function and my first function output. Guys, is it clear? Let's just have a look once. Okay, fine. So all good. Let's go ahead and check some more discussions. Like when you start working, so there will be a lot of confusions happen. So let's clear those confusion out. Okay. Now we saw your function definition. Now if you can ask me, like if you have worked in any programming language earlier, so you can ask me that. Oh, I've just written a logic here. Okay, so there's nothing. I'm not printing anything. Okay, neither I'm writing a return, because other programming language accepts return. Okay, return, what the function will return. Neither I have specified the return type. So basically, again, if you recall it from other programming language, so they ask a return type. Okay, so what will be your return type? Okay, so will it be integer, void, characteristic? So I have not specified anything. So that says our functions are very light and self-understood. Okay, so here they don't need all these things. So it simply, this is a scrape for R. If you don't give, it works. If you give, it's fine. But if you don't give, it's perfectly okay. You just write your logic, and based on that logic, this logic will be your output. Okay, but if I even give print, okay, I even give print and bracket and run this again and call my function, I get the same output 100. Okay, so there's no changes in this. Okay, now let's say like out of, I don't want for 10, I want for 5. So I can change my parameter and my function will return likewise the output. This is fine. That is the use of function. So you creating it once and using it multiple number of times. That is why function, we create a function. Right, now let's say, for suppose, I don't want square, I want a cube. I change the logic. Now if I come here back and I run it, so I still get a square. Any idea what is the issue?
You didn't run the previous logic.
I have to run the
Logic.
Okay, basically what there's a concept here. So whenever you create you define a function, okay, the definition, if there is any changes, okay, and you compile it. So once you compile it, and that is what the function becomes. Okay, and if you make any changes, in the function, you'll have to recompile it. Okay, so this is logic. So the latest version that you have compiled will be always called. If you want to make any changes, you have to make the changes, okay, and recompile it. So whatever you see here, if you see my first func, and if you click on this button, okay, you will get the if you are confused that which logic is there, if this function is not created by you and you're not sure which logic is implemented, how to make changes, is it getting implemented properly or not. So you just go here, this the function name, and click on this button. So this will open the code. Okay, so you see here, this opened a new tab, my first function, and it gives the complete logic. So I did not compile the changes, these changes which I did not compile. That's why I still see the old code here, which is a square. So if I want to see the changes of cube, so I just need to go there, compile it again, and then again open this. So you see the changed code is getting populated here. Guys, is it clear? Okay. Now, here in this same function, so there are few things that I'll talk about. Okay. Before that, one question for you. Okay, so the question is, in this function, I have a vector. My vector is, let's say, one. My vector is 1, 2, let's say 5, 10, 15, 20, and 25. This is my vector. Okay, I want the square of each element. How do I do that?
We use for loop for when we call the function.
Using function.
Yeah.
Okay. So I want not by loop, I want by function. Guys, just try it. It's very easy, simple. Use functions only. Don't go for loop. So for loop also, you can do it, but let's do it for only using function, no loops. So this is your first we'll see using function, then we can go ahead and see using loop for loop. Yeah. Can somebody try? Who can try this? So I hope you got my question. This parameter, this parameter or argument is not supposed to be only single element or only a integer, only a character. It can be anything. Okay, so for this example, I was trying to take a vector. So let's see, like my second vector, the second function. I'll create my second function, and what this function will do, I'll simply pass x, okay, and bracket. So, and here I'll do x into x. Now I'll create this function, let's say, and my x, I'll pass this as x. Okay, my second function, okay, I'll pass. What I can do is I can even create a separate variable and assign my vector to that, like this. You can do this, okay, or simply you can pass this, okay, directly. Let's check. So what I did is, rather I don't want to take extra pain of creating a x and then passing x. I can directly pass the vector as my parameter, right? Is it okay?
Yes, sir, I did this.
Yeah.
I
So
copied it in the chat.
correct. So you can do this. So now we got little understanding of how the parameter like behaves. Now, second thing that you can think of is, let's say there are two vectors. So you have x, and now you also have y. You have y, which is c, 30, 35, 40, and 45. So this is your c. So now what will you do? Now you want a square of x and a square of y.
So I'll write x into x plus y into y.
X into x plus y into y. No, that will not work. Try it once. Try it once in your system. So I hope you got the question. So question is, yeah. So question is, I have a vector x and y. Okay. So use function to get x square, and y square. So I want two vectors. One vector, let's say output will be something like this. This will be the output.
Okay.
And second vector will be output of this, square of this. So one vector will be square of this, and one vector will be square of this. I mean, okay. So you got one output, right? X square of this. So you want the square of the second vector as well.
Sir, here should I have to take two functions for the two variables?
So that's what. So try it in your system. What your intuition says. So when you have multiple inputs, so that means you have multiple parameters. So for multiple parameters, you can pass separated by comma x comma y, and build the logic inside the function definition. And whenever you want to, once you have compiled it, so whenever you want to call your function, okay, whenever you want to call your function, you just give a function name and the number of inputs you want to get evaluated or calculated. This is how it works. Okay. Now, tell me one thing. We defined x comma y, okay? And if I gave x comma y, so in whatever definition I have defined the function, in the same sequence, I have given the input as well. Now, what will happen if I do this? I pass y first, comma x. Definitely, like it will run. Do you have any doubt it will run or not?
No, it will run, but it
Run.
first the y square, then x square.
Okay, so it will give you y square, and so first it says it will run, so that is fine. Now second is, once we are running it, we'll not get the output in proper sequence. So our output is getting reverted. Okay, so a person who is new and who are not aware with this function definition, so might get confused. This is x square and this is y square, which is actually wrong, right? So that means we have a limitation. We cannot, we'll have to somehow match the sequence in which we have defined the function and in which we are calling the function, right? So far that is the case, it looks like, at least. Okay, so then comes our second point. After argument and parameter calling, like giving multiple parameter, calling multiple parameter, then comes the second point, which is your argument matching. Okay, and we saw that function was not able to match the, I mean, like, what matching? So we passed in x and y, and as an input we passing y and x, so we are getting y first and x second, and that is how the function definition is. But it was not matching with the input parameter. Input was first x, then y. So what can we do? So if in case we are not sure in which sequence the function was defined in taking input, so we can pass the parameter with the input name. Okay, so if we know this is your y, so just pass y is equal to this, and we know this is your x, so pass x is equal to this. So now if you run this, so you'll get, irrespective of order, whichever come first. Okay, so this will match the input parameter and your output will be proper. Now check this and this, they are in the same sequence. Does it make sense, guys? So function has this capability, particularly R function. So some programming language has this limitation. You'll have to pass the input in a format wherein in the same format in which the function was defined. But here, argument matching, there's a term called argument matching which exists in functions of R, where your arguments, if you name them, will be matched with the function definition, and then it will get evaluated. So it has made our life very easy, right? Okay, so irrespective of in which sequence I give, if I'm giving a proper name of the input, so that function will take care of that. Okay, now, so that was our second point of discussion, and defining function. This is done. This is done. Let's go ahead and check some more logics. Okay, which is called your local variable and global variable. Fine. Now let's come back to our example. So let's create another function called my fourth function. Okay, and here I will create a function as usual. I'll pass x. Okay, and x will be your print x. Okay, simple. And what is my x? My x is, let's say I'll define x here. My x is step up analytics, right? This is my x. Now I call this. Okay, I've called a function. Why this x is not getting printed? Any idea? I have passed the value of x here, which is step up analytics. I'm printing the value of x here, but this x is not getting printed.
Function only takes the numerical value.
Okay, functions take the numerical value. Okay, so let's take this x is equal to 10, right? So this should print according to you. I should get an output of 10.
Sir, we haven't write my fourth function bracket x and then run it. We have to write it again and then run it.
Okay, so we'll come to this. So this let's run this. So this is not giving this is not giving 10. So this theory failed, like a numerical value and character value, right? Now let's come to the second points which she made, which was called
My
the
fourth function,
yeah, my
then
fourth function,
x.
and then x. Okay, so what will this do basically?
This will print the value of x.
This will print the value of x, and x is like, though I have called value of x and function together, so it should have taken the value of x, right?
Yes.
Actually, this will run the logic. We by this my first function of x. By this we call the function to compile the logic and run.
Okay, so the thing is, guys, so it works in this way. The concept is, irrespective of what x is, integer, character, okay, irrespective of x, wherever it is defined outside a function. Okay, so whenever we talk about this x, okay, so this x is like not a normal x that we have defined here. Okay, so let's take one example. You will get it here itself. So let's check it here. So whenever I define a function, so I'm defining this. I define a function in x. So this x which you see here is not anything that is like other variable x, y, z. It's this x is not this x, first of all. Okay, this is something local to function. So whenever you define a function, this x becomes the function understands this x is a local function which is inside the function. Okay, so whatever value you pass here, let's say you pass 10, or let's say you pass Sajid. Okay, so this Sajid will go here, in the place of x. Okay, and then it will go inside and Sajid will be printed. Fine, but since I'm allocating Sajid to x, according to you guys, like as you said, this 10 should be replaced by Sajid in x. Should it be? Any idea?
Yes.
Obviously,
Print
should be,
Sajid.
because I am passing x. In place of x, I'm passing Sajid, and x Sajid, it becomes x, and x gets printed out, right? So let's check it. So I pass Sajid. I'm calling this. I hope I have compiled this function. Okay, I have compiled this function. So my fourth function is here. Okay, so I'm sure it is compiled. Now I'll call my fourth function, and I'll call this my fourth function, and I'll pass Sajid to it. So according to the logic, it is printing Sajid. Okay, so that was expected, and since it is printing x, so x is Sajid. So now if I just type x, so we should get Sajid or 10. Now if I just print x, what should I get?
10.
Why? Like somebody just said, it will get overridden. It will just get overridden.
Because we are not calling the function here. We only just taking the value of x. Here we don't call the function.
Okay. So,
No,
but
actually at first we store step-up analytics at x, then we store 10, and the last thing it will remember that it will take 10 only, because at the last step we have stored 10 at x.
but we printed x, and x was Sajid, right?
Oh, okay. No, but here we did not define x equals to Sajid. We we passed Sajid, and it take as x equals to Sajid in including the function. It's in the function. In outside of the function, x it's another variable which store 10 only.
Okay, so though I don't know what. Okay, so it was not clear to what extent I don't what you're saying, but see.
Actually, I am saying that if we passed Sajid to the function, then the local variable x becomes Sajid, and x takes Sajid, and for that function only. But outside the function, x is another variable which takes 10 only.
Okay, so you mean to say that for same x there are two different values.
Yes, for function x becomes Sajid for function because we passed Sajid. We did not say that x equals to Sajid here. If we said x equals to Sajid, then the function.
Okay, fine. So fine. So let me fulfill your dream then. Okay. So x is equal to Sajid here. Fine. Now I'll run this, and I print x. Now I call function my Sajid, and Sajid is getting printed. Now if I print x, what I'll get?
Till 10, because we defined x equals to Sajid in the function.
Don't if you guys are going and seeing this value, this might make you wrong, right? So don't look into this value and answer me with the logic.
Sir, you told that these two x's are different. So
which two x's?
The x equal to 10. This is variable. We are storing the value,
Okay.
but in the function x, here we creating a function. It is not a stored variable.
Okay, fine. So let's come to, I'm getting like a little mixed answer. So let's come to the concept now. okay, directly. So guys, the thing is, whenever you define a function, whenever you define a function and you define a parameter, so you have this parameter. So parameter is kind of a variable argument that you are passing. This is a variable that goes inside this argument, gets evaluated, and that you get an output. Okay, so whatever happens inside this curly braces, whatever declaration, calling, printing, logic evaluation inside this curly braces are called local to this function. That variable or argument is called local to this function, my fourth function. Okay. Now this x is equal to Sajid is obviously local with the definition which I have given you, because this is defined. This is defined inside the braces. This is local. So the moment function executes, so it executes from here. It comes here. It defines the value x equal to Sajid. It prints it. The moment it comes out of the function, this value is getting flushed out. So this value does not exist. Okay, and this value does not exist. That is why you don't see anything in the global environment. So in global environment, you only see that value which are global. Okay. Now this obviously is not in the global environment, so it is a local, and it is only understood by the function and during the execution of the function. Once the function execution is stopped, the value of x is flushed out. Fine.
Yeah.
Does it make sense? Like, does it clear out your concepts?
Yes.
Yes, yes.
Okay. So that's the reason your x10 is your global and this is your local. Okay. There's nothing. There's no logic that this is a string or character. So nothing works. So if it can take x can take any x can even take true and false. Okay. So there's no limitation with the parameters or the argument which it accepts, right? Fine. So that was one thing, global and local variable. Now, if you think in this way, that okay, so we'll come to that concept. Now, let me check. Okay, yeah. So let's come to functions like whichever we created. So whichever function we created, so this is a user-defined function, obviously. Now I want, let's say, to see the structure of a function which was not created by me, but it's a user-defined function, but it's not created by me. I want to see the code. So let's say you just have the function name and this is flushed out. Okay, I mean, like you are working in a server or something that kind of setup. So you just put str and my function name, so you'll get a attributes and all the logics here. So this will help you. Fine. Now let's create one. Let me check my one. Yeah. So let's take one example. Your function. Let's create a function. We all have dealt so far with a numerical function, numerical parameters. Now my parameter will be, my first input will be my first name. Enter your, let's say, x or first name. First name will be your one parameter, and then will be you have second parameter as your last name. Right? I want a function wherever you enter first name, let's say function fun. Okay, you enter first name, comma, last name, and your output should be something like this. First name, space, last name. Yeah, guys, can you try once? try and recollect your concept from there. Will this function which I've defined here with two arguments x and y, okay, this is the function definition, and when I call the function and I just pass one argument and run it, what will happen? Okay, it should not run. Okay, ideally, if you see function from the eyes of other programming language, it should not run. Okay, it will give an error because definition mismatch. This will be a plain error, definition mismatch.
Sir,
Okay, but here,
yeah, sir,
yeah,
sir,
yeah, tell me.
can it?
Basically, there's a concept called lazy evaluation in R, and all the functions that you see that you use that are evaluated lazily. That is, I mean, like it follows the concept of lazy evaluation. So it is not that if the definition is mismatched, it will give you an exact error. It will not compile the function itself. So what happens in R is whichever part is right, they'll execute that. So that means since function is getting evaluated from top to bottom, okay, here like x got evaluated, then y got evaluated, and then it ends. So whichever part is getting evaluated perfectly, that will run, and rest will just it will throw an error and it will come out. So if I run this, so I'll get 10 as output, okay, but in second line here the 10 will be there because 10 I have passed 10, right? The first argument I have passed, so it will print 10. Okay, the moment it prints y and it sees that y was not passed, so only this part will throw error, this part will run fine. So let's check it. So see here, so I got 10 printed, okay, and in whenever it says y has missing with no default, right? Now if I say something like this, y is equal to 0, guys, this is conceptually very strong. You are trying to understand behavior of function. So just try and understand what I'm doing and what I'm telling, so that whenever you start looking into a real function in your work, you don't get confused, because this will what happen, and there you don't have a proper document which explains you each and everything, each and every scenario. So I'm trying to cover all possible scenario which comes in real life. Now if I pass x and y is equal to 0, and then I print if I compile the same function and call 10, what will happen?
It will print 10 and 0.
10 and 0.
Yes, 10 and 0.
Now if I pass 10 and 12, don't run and check it. That will definitely give you an answer, so it no point in like asking you. So you can try it. So try and understand the concepts. What it will give you.
Since y equal to 0 is in local environment, so if I print 10, 12, so it will print 10, 12.
Okay, so
I thought it is also 10, 0.
Yes, I think also that it will be 10, 0.
okay, and what makes you feel that? Any logic behind that?
Because I already stored 0 in it, creating the function with y equal to 0.
But that's in local environment.
Okay.
I can't change the function.
So I compile this.
Whichever value we give to
I
y.
write this. Okay, fine. So let's try and understand this. So whenever I create an argument, okay, I've created an argument. This x and y is my argument, right? And here, if you check, what was the error? Error in print y, argument y is missing with no default value, with no default. So like this is the reason I'm trying to focus. Whenever you see with no default, so it means whatever you give here, whatever value you give, so that is assumed to be a default value of that parameter and argument. Okay. I gave y is equal to 0, So if in case I don't pass, if I don't consider this argument while calling my function, if I don't pass any argument which relates to this, okay, function will assume this as a default. Okay, but if I pass a value of an argument, it will override the default and it will show you the value which you have passed. Okay, now if you run this, check here. So you get 10 by 12. You get no more 0. 0 is overridden by, since 0 was a default, so whatever you pass here, whatever value you pass, so even if you pass x is equal to Sajid, okay, x is equal to Sajid, and compile this function, okay, and now you pass x is equal to 10 and 12. So somebody might think the function definition, x is a string, okay, y is an integer, so default value of x is a string and default value of y is an integer. Now if I run this, what will I get? So this is little complex now. You can run this if you want. You can run this in your system and check what, because this is a little complex. Yeah, because the whole concept of your local variable and global variable relies on all this understanding. In my function definition, I'll just repeat once again, okay, if that clarifies your doubt. So doubt is general. That's the reason I'm trying to emphasize so much in different cases, and it's very confusing. Function, when you deal in function in real life, you'll get such scenarios. So I talked a lot about function definition and this and that. Okay, now I have created function. I've compiled this function, and what the function definition is: function accepts x, which is Sajid, which is a character. Function as a default value. Function accepts has a parameter y with a default value of 0. Right? I've compiled it. Now I'm calling a function. I'm passing 10, which is not going well with x because x is a character. I'm passing 12, so fine. So 0 integer and 12 got evaluated. Okay. Now if I call this, I even get output, but the output will be your according to the parameter or the argument that you have passed. Okay. So the model of the story here is you define a function. In function definition, whatever the type is, okay, this is a local type. Okay. And it is assumed to be default. Default can be anything, but the end story, like whatever you call, that will be considered and taken ahead. Okay. Do let me know if you have any question. I can spend some more time in here. Okay. Now, this was default value. Okay. So let's see what happened to my system. One minute, guys. My system is getting heated up. So let me close some tabs. I don't know what is the issue. Okay. Fine. So my next concept. Okay. My seventh function. Let's say, like C number is increasing, but yeah, my seventh function. And what I do here is I create a function x comma y. Now my x is, I'm defining x as 10. Okay, and printing x comma printing x print y. Okay, so this is my function. Have a look. Now I'm calling my seventh function, which is this, and I'm passing Sajid comma 10. Any idea? What should be the output here?